quick video update. I figured I'd get this video update out there. I did what some people suggested. I further fine-tuned the quarter-sized pickup coil coming off the transmitter, and the quarter-sized pickup coil feeds an inverter, an AC inverter, that converts the power to 120 volts AC to power loads. And we have a clamp meter over the load reading, I don't know how accurate it is, but it's reading about 350 milliamps, and that makes sense. We're running about 45 watts worth of load here, a 40 watt incandescent and a 5 watt LED at 120 volts equals a current draw at about 350, 360 milliamps that the meter is reading, the clamp meter. Also, what I did that another person suggested is the high frequency signal is present everywhere in the system, contributing to this loadless wireless power effect that you see in the little LED receiver lights. And what I did is I have a reverse bias diode connection. I also have the transmitter's driving battery connected in parallel to the quarter-sized receiver coil through a reverse bias diode, so only the high frequency power can pass through. That seems to be built up in the battery, that will actually zap you and can light incandescent bulbs if you hold it to either the battery or the resistor shunt network that feeds the transmitter. As you see, look at this. I'll try and get you a good look at that zoomed in. I think my hand's in the way. Hold on. I'm trying to film one-handed. It's definitely present on any connection within the transmitter. Yeah, right here. So, we're basically harvesting that high voltage back EMF, and it's going through a reverse bias diode off the battery, enhancing the quarter-sized receiver coil's output further to drive this inverter and run substantial loads. There's an analog voltmeter hooked up to our transmitter's driving battery, reading almost 13 volts DC. So basically what's occurring here is I took the principle from my last video and applied it here in a more constructive way, more precise way to benefit us. 12 volt driving battery gets stepped up to 96 volts DC, passes through a resonant carbon film resistor shunt network just on the positive line, goes through a current meter, feeds our transmitter, which is a heavily earth grounded Joule thief transmitter, which is auto tuning with the earth, the ground connection. If I touch this little detector receiver light on anything metal, it'll glow very brightly without placing any form of load on the transmitter. That's very bright over there, actually. And good look at the little receiver light. And basically I took the principle of this reverse bias diode connection, and basically the transmitter's driving battery is hooked in parallel to the quarter-sized receiver coil to enhance the power output, but the connection goes through a reverse biased SR560 diode, so only the high frequency energy can pass through, further enhancing the quarter-sized coil's driving output to power up this inverter that can then run 45 watts worth of load. And it can even run 80 watts worth of load. I'll hook up another incandescent bulb. So we're taking the correct principles applied here and trying to utilize them properly. So that's 80 watts worth of load now. See if our voltage dipped a little bit. You'll have to forgive the mess. It was clean this morning, but experimenting, refinements, and building kind of made the immediate work area a bit of a mess. We're at about 12.5 volts. So that's about 80 watts worth of load. Now we'll see what the current meter says, if it's accurate, because those are two 40-watt bulbs. I know that one says it on the top, 40 watts. Can even hook up, well, that's hot. You can hook up another 40 watts. So we definitely know that's 80 watts, and it's fully lit. That's 80 watts. 40 there, 40 there, and this is only a 150 watt output inverter. It's upside down, go figure. It's a 150 watt inverter. So we're nearly maxing it out. And I hear it humming slightly louder too. Clamp meter is fully clipped over the connection. I don't think that's accurate though, what it's reading. And it is set to AC. You could look at the leads. It just connects right to the inverter. And there's some serious heat going on over here. So again, to sum it up, we took the principle from my last video and employed it properly of the reverse bias diode connection, utilizing it for proper power collection. And something weird is when the circuit is running in this way, and if you were to bring in an external earth ground connection through a reverse bias diode and run a bright light like I did in my past video, the light bulb almost wants to blow up. Like, that light bulb will light up bright as quick as you can tap it, and it's very hard to tame that power, at least from an earth ground connection. So figure I'd mention that. And the last video shouldn't really have even been posted. It was just rough, quick lab footage. But we're sustaining 80 watts worth of load, and yeah, it's looking pretty good. Still at about almost 13 volts on the analog amp meter. Still have wireless power present. That loadless wireless power present that lights up when you touch it here. Still that strange resonant energy buildup in the system that's very strong. That'll also do this, as you see. So, very interesting. Good look around everything. No hidden Tesla coil anywhere. And there's just a lot of heat in this area. So is this promising? Who knows? The correct way is to probably then send this through an isolation transformer and pulse the output. When I disconnect these loads, it should recharge itself. That's really hot. So we'll see watch our voltage for a minute as the loads are disconnected. I think it's creeping back up. I'll zoom in more. Kind of a poor meter to see if we're slightly recharging. But right at 13 volts. We are running 80 watts worth of load. I'll cook them back up. See the inverter here. Again. and it's all from that reverse bias diode connection that was installed on our special quarter-sized receiver coil with our resonant capacitors. So I hooked up the 80 watts worth of load, and it dropped us to about 12.5 volts under load. I believe the frequency is 145 kilohertz. Could attempt a quick frequency check. See if we can do that real quick on video. Clear some. Ooh, careful. Clear some shit out of the way. I don't know why this thing loves to fall forward a lot. But okay, here we go. Certain people love seeing a frequency. And this thing is emitting such a powerful field you can detect the frequency without touching it to anything. Yeah, 105 kilohertz actually. Frequency was brought down slightly from running the load and also trying to recharge the battery wirelessly from the quarter-sized output. And the power is very spiked. It's a spiked waveform. A lot of energy contained in each one of those spikes. So again, to sum up what's occurring, we have a 12 volt driving battery for the transmitter, gets stepped up to 96 volts DC, minimal current required for abrupt unidirectional DC switching to occur, passes through a series resonant shunt network on the positive side that feeds the transmitter. Negative side feeds through a analog current meter. We're drawing about 200 milliamps at a 96 volt DC input, a little less than 200 milliamps. Goes into our heavily earth grounded nonlinear Joule ringer circuit, modified for energy synthesis theories based on Eric Dollard's work in theory. We took the concepts from the last video and from some other people of using a reverse biased diode connection, and we combined the battery's power with the quarter-sized receiver coil's power to be able to do this. But the key was the reverse bias diode connection in the line in series, going into the receiver coil. And there's also a powerful buildup of resonant energy in the system from the ground connection, and it can even light little light bulbs in my hand when I do this. Like, how crazy is that? My hand's in the way a little bit. There we go. That's a better view. Cool, huh? And it'll even make a fluorescent tube glow at that spot. Hopefully I can show that. See if I can show that. I'm gonna have to hold my hand closer to it. It should light. There we go. So the resistor shunt will actually act like a very crude Tesla coil, which is absolutely crazy. And doing this will slightly draw power from the transmitter because you're technically detuning it. But try and get you a better view of that. Here's the fluorescent tube. I contact it to the shunt network. I have to hold my hand close to the base. And that actually even lit up just bringing me close to it that time. Yeah, it's lit right now. See, it's lit right here. And things are just freaking out. Yeah, it's still lit. The fluorescent tube is lit. So I'm going to put this away. And there's some type of powerful resonant buildup within the resistor shunt. Voltage is still holding steady, almost at 13, sustaining 80 watts of load. That can't be accurate. It's catching interference from the wireless signals that also are responsible for lighting this. But still, it's good to have on there. I don't think that reading's fully accurate, unless even if I touch my hand near it. I like the analog meters the best. You know the analog has to be accurate. Give you a step back and look at everything. So we're sustaining 80 watts worth of load. 40 watt bulb, 40 watt bulb. Almost maxing out the little inverter. I think this is the way to go now with the system. So it's showing a lot of promise. And I applied a lot of concepts to my book I recently wrote called Understanding Energy and its Various Arch Forms. And a lot of research into Eric Dollar's work and Ken Wheeler's theories went into that book. So it's showing a lot of promise now. You can just feel the heat coming off that. You could look at everything. These were just various light bulbs laying around. Try and clean it up a little bit. It's a little bit of a mess, but it's not that bad. I was just experimenting. It's not too bad of a mess. Don't even need this little meter anymore. Found these screwdrivers I was looking for. Just get some shit out of the way for you guys to see. A little bit of a cleaner space now, so it's not that messy. Except my wiring connections, it's got to be cleaned up a little bit, but it's not that bad. Get rid of the crap I don't need. This I was experimenting with. This quarter-sized coil will rapidly recharge 9-volt batteries. This is just an antenna connection I have that goes to a plate in my window, a metal plate. That'll also light up the little LED. Just to a metal plate in my window. So, really cool stuff. The system can pull in more energy from the environment. That's what it's showing. Anyway, we're not using that, so I'll get it out of the way. Good look at how the reverse diode connection looks. Isolation capacitor, capacitor in parallel to enhance the power. And this would be connected in a backwards direction coming off your battery. So in a normal traditional system, the direction of this diode wouldn't allow current to flow. But in this high frequency system, reverse biasing the diode off the battery allows significant high frequency current to flow that will go into your quarter-sized coil and enhance its output to drive big loads. And apparently it can do significant work, and the energy may even be flowing backwards in time through the reverse bias diode, but I don't know if that's the case yet. More testing's needed. And I think our voltage is dropping a little bit now. We've ran 80 watts of load for a while now. Approaching 20 minutes, I believe. These meters just sit here. Another good look at things. Good amount of heat in this area. There's a lot of heat in this area, actually. I'll actually try disconnecting it now. Move some more shit out of the way, give you a better view. So, good view behind it. Even move this a little bit more. So we're not even using this. Oh, and how cool is this? Check this out. The system extracts energy out of nearby metal objects when it's on. Weird, right? This is that loadless wireless power field that I was telling you everyone about. So anyway, I'm going to disconnect the 80 watts worth of load now, and we will see how fast our battery recharges from the receiver coil, the quarter-sized coil. So, oh my god, that's hot. So we're disconnected. Let's see what our voltage spikes up to. Almost right back up to 13, where it was originally. The high frequency should rapidly recharge the source driving battery. And the excess power is being pulled in from the ground connection and being dammed up by the resistor shunt, which is a 100 ohm carbon film resistor shunt. 25 watts worth of resistors there has to be carbon film with a resonant LC network. And the system just basically rapidly recharges. Little fan kicked on in my inverter. We'll run the 80 watts worth of load again. See what happens. And yeah, it seems to show success. And this is only a 6 amp hour, 12 volt DC, LiFe P04 driving battery doing all this. Enhanced by the energy synthesis ringer power system. It's showing a lot of promise. Much more refinements are still needed to it. Recent research, including the reverse bias diode connection, really helped. So I figured I'd document all that, show you guys. And even if you don't use that reverse bias diode connection, just this coil is capable of very rapidly recharging 9 volt DC batteries, like super fast. And just slide adjusting the coil into proper position will cause the rapid recharging to go crazy. That little LED is actually just barely lit sitting there by itself. The wireless power field around this thing is just crazy. And it's hyper efficient too. It's almost like there's a multiplicative field-based effect around the system that's almost like magic. A multiplicative field-like effect. Better view with the analog voltmeter. Yeah, still holding steady at 12 volts. Sustaining an 80 watt load through the reverse bias diode connection that's in parallel with the quarter size receiver coil, driving the inverter, powering the 80 watts worth of load. The reverse bias diode connection was key. With high frequency systems, the energy works really interestingly. Sometimes a lot different than what you think it would, how you think it would act with normal conventional power. Good look at the inverter again. Show you that everything can be picked up and easily moved. I don't want to short anything out. So that's how that looks. I might go on to 30 minutes, I'm not sure. I'm starting to run out of space a little bit on my phone. And if you build this and want to test it further, you can also use a very small and weak ceramic magnet to fine-tune the system further. Yeah, a little ceramic magnet. That's on full power. Yeah, you can really feel heat off that. And these wireless power effects are just crazy. And if you doubt the system is doing that, I'll shut the switch off, shutting everything off. And everything is off. Even the transmitter is off, not drawing power. Wireless power field is out. And the strangest thing is, since I added that reverse bias diode connection in the line, sometimes the system has trouble starting and turning on from the switch here, which doesn't make much sense. I'll try turning it on. See, now it won't turn on. That's weird. I don't know why it does that. I have to like rapidly flick the switch to get it to turn on. I don't know why it doesn't want to turn on now. I don't know if it's a problem with the switch or if it struggles to start from the reverse bias diode connection, but this is just weird. I can eventually get it to start again if I disconnect something here, I think, and then it will go. Nope, it's still being difficult. I might just need a new switch. I don't know why that switch is doing that. And actually slightly move this. What is going on here? Sometimes this thing acts so weird. I don't know why this won't switch on. Very strange. And why is it when I throw the switch, the analog voltmeter drops? What is going on? Maybe I have a bad switch. This is weird. Okay, now it's on. See, I don't understand what just happened there. Something like weird going on with the switch, and sometimes it acts in unpredictable ways. And now the transmitter is consuming even less power. What is going on? 50 instead of 200. See, sometimes it just acts weird. Still working as intended, though, it seems. I disconnect these loads. What is going on? Anyway, I'm going to disconnect these loads and we'll watch, see what our charge is. So we ran 80 watts worth of load and we really didn't even use a charge from our battery because of the reverse bias diode connection that comes through. So there's some type of charge blocking occurring, or maybe the energy is somehow flowing backwards in time, but that meter is also going up to 13 volts now. I'm not sure what that difficulty was earlier, where the system didn't want to turn on from that switch. Here's the wireless power effect still present around the device. The near magic-like properties. The loadless wireless power effects. Good overview of everything. It's pretty small. Battery isn't hot at all for what it was doing. Charge levels at 13 volts. What's occurring is when I stop running this load, the quarter-sized receiver coil takes over and attempts to recharge the driving battery back up to a state of equilibrium. And it's taking advantage of these loadless wireless power effects, meaning when this lights up, especially in this way, there's no load put on the transmitter. So, and the interesting thing is we're drawing even less power now. So, I'll hook these back up, give you a good look at them. I'll even unscrew the bulb for you. 40 watt, 120 volt AC. Good look at the filament. Connect our loads back up. Oh, I didn't show this one, but you get it. It's just a light bulb. You can move it too if you want. Just gotta be careful not to short anything out. Although we're nearly maxing out the inverter. So, good look under the desk. Nothing hidden anywhere. All my crap. Doing a full 360 here. Another good look at the inverter for those who want it. I'll even remove the current meter now. I don't think it's much help anymore. Oh, and here's the other weird thing. Look what it reads when I clamp it over certain parts of the circuit here. I don't think that's accurate. It's saying there's 15 or 16 amps going into here. That doesn't make sense though. That can't be accurate. And there's pulse DC coming out of this coil with a very high current contained in the abrupt spiked waveform. So that makes more sense that it's 1.20 amps AC. See what our voltage is at. Seems relatively steady. I'll disconnect the heavy load again, and it should recharge itself. Damn, those are hot. And the inverter has a little fan that kicked on. And the source battery is attempting to recharge itself to equilibrium from the quarter-sized, loosely coupled Tesla receiver coil that's hyper-resonant, taking advantage of the loadless wireless power effects that also lights this little receiver light wirelessly without putting a load on the transmitter. And like I said, the system's pulling in energy from the ground connection, accumulating it, and the resistor shunt is capable of doing this to an incandescent bulb. Very interesting. It's in a more stable form of operation than in my last video, the longitudinal form of operation. That seemed very difficult to tame and control. I couldn't even measure the frequency. So we're just about back at equilibrium. And again, we have a huge potential difference established between the ground connection, the resistor shunt, and then here's our substantial load. 80 watts worth. And that's just bright. I'll back up and give you a good look at it. And my phone's spazzing out being near this thing. Everything's kind of spazzing out being near this thing when it's in like this hyper resonant state. Here's the most crazy. I'm like 4 feet from the transmitter, and look at this. So that's lighting up on just a piece of metal here. There's definitely something strange and not normal occurring here. Also, just a metal storage desk. Look at this. Very strange. How can you not see that and be like blown away at how weird and interesting that is? So, and the range is just fantastic too. There's a powerful field all around the device. A multiplicative like field. Looking for a little detector tool I had, but I might have... Oh wait, no, it's over here. That's what I was looking for, this thing. This should detect pretty powerful fields around the whole system. Yeah, they're just going crazy. Look at that. There's just very intense fields around this thing. Oh my god, that's intense. Especially around the quarter-sized coil. Very impressive. before I can conclude this video, I'll show you else something very interesting. Oh, fuck, I just burned my hand. Jesus. But, anyway. Where'd that little thing go? Oh, yeah, this thing. This is how much of a powerful field is around the system. Watch this light. This LED receiver light. Not much there, right? But then I take the tuning ferrite bar, and it's like we can manifest power by properly tuning the ferrite bar. And there we go. We have now... It's always shit in the way. There we go. Got that a little better, I believe. Yeah, there we go. So I'm pretty much manifesting power in that receiver coil by tuning it with the ferrite. Oop, that's very bright there. There we go, that's perfect. That's good for the video. I just fucking burned myself from that light bulb. Jesus. But yeah, reverse bias diode connection. Potential between the earth ground and the resistor shunt. Loadless wireless power effects, taking advantage of that. I showed you how we're basically manifesting power by correctly tuning in to the field present around this thing. And I want to see if I can get the range real good. Yeah, so there's a good idea on the range. If you touch this, it probably gets brighter. That really hurt. Part of my arm just contacted the light bulb. But, sustaining 80 watts worth of load from this thing. Oh, and there's a very intense field around the battery, too. I'll show that. So, there we are near the battery. And we're taking advantage of all these weird field phenomenon occurring. Good idea of how far we are. And when those light up, there's no load placed on the system. So, again, a good look at the power built up in the resistor shunt network, and that lit again just getting near it like a Tesla coil. The resistor shunt network will act like a crude Tesla coil. It's accumulating a massive amount of power somehow. A big potential difference between itself and the earth connection that the receiver circuitry then utilizes, along with a reverse bias diode connection through the driving battery that's connected in parallel to the quarter-size receiver coil's output that can drive significant loads. So I'll put that back over here. Gotta recheck the video and see how long we've been running 80 watts worth of load for. Full intensity. Thing freaking burned me. I'll even disconnect now and we'll see if the system recharges back up to equilibrium. Shit, those are hot. I have to start wearing some kind of little glove. And notice how when these are disconnected, there's no change on this thing that's outputting power, this wireless receiver. So the system is attempting to recharge back up to equilibrium again. I actually think it's right at 13 volts. It's like we never used any power. Because we're technically tapping into the huge potential difference between the shunt and the ground connection. And the catalyst is the reverse bias diode series connected with the driving battery that's in parallel to our quarter-size pickup coil that's wireless. Ideally, it would be best to have it perfectly centered in there, but it seems to be tuned up pretty good. we're right back at, what is that, 13 volts, 12.8. We'll run the loads again. Seems to be working pretty good. Definitely enhances your run times. And this thing burned the shit out of me. How's that for a look under the disc? So, nice illuminated view. Don't know what else there is to show or explain about the system. Takes concepts from Don Smith, Nikola Tesla, Eric Dollard, all the others. And yeah, basically tries to apply them using retroduction in a very logical fashion to make useful power, because any generator just takes advantage of the potential difference between 2 points, and in the middle of which you put your load. So that's what we're trying to do with our ground connection and our resistor shunt that acts like a crude Tesla coil when you go near it. And yeah, just crazy stuff goes on with it. I've never seen that happen from a resistor shunt. So it's like we're taking the longitudinal power that's generated in the system and converting it to regular power in a controlled way. So I think that'll conclude the video, and thank you everyone. Feel free to like, comment, subscribe, join the Patreon, support us on YouTube, and to also check out our new book for only $5 that describes a lot of this stuff, how to build it. And we actually just shut off. Oops, it's coming back on. Probably maxing the system out, or I didn't leave the load disconnected long enough for the battery to recharge itself. But yeah, thank you everybody, and we will see you next time.